All right, welcome. This is going to be the first packet for Algebra 2. This is going to cover linear equations and graphing linear equations and the basics of a linear equation for slope and several different things. So we're going to get started with a little bit of the basics with how to graph points expressed as ordered pairs. So this first problem just says graph the following ordered pairs. So a couple reminders whenever you're graphing. Remember you have this grid, this coordinate plane, and there are two axes, and you have the x-axis, which is the horizontal, and the y-axis, which is the vertical axis. And so each of these points up here in the problem, they give us the set. There's 1, 2, 3, 4, 5 points. They're giving us, each time they give us 1 point, it's an ordered pair because the x value will come first and then the y value will come second. So the x coordinate is 2 and the y coordinate is 6. So what that means is in order to find the location of this point, we're going to express it with a dot on the coordinate plane, is on the x-axis we have values. Here's 0, 0, and so if I go to the right one, that's positive 1, or if I go to the left one, that's negative 1. Well, I want to find positive 2, so 1, 2. So that's 2 units for x. And then for the y value, as I go up, they're positive. As I go down, they're negative. So if I want to go to 6, just go up 1, 2, 3, 4, 5, 6, and this is where I'm going to make this point. So I have a point here at 2, 6, about right there. Okay, and then that's what you're going to do for all these points. So you have this negative 3, comma 3, which would be negative 3 is negative 1, 2, 3, positive 3 for the y value, up 3. That's where I want to put the dot. So negative 3, positive 3, right there. 0, 1 is this point, 5, negative 2 is this point, and negative 1, negative 4 is this point. All right, so that's basically the gist of graphing ordered pairs. So you can go ahead and do number 2 as well, but hopefully that was helpful just to give you a quick reminder of how to do that. Number 3, this next section of problems, we want to find the slope given a line on a graph. And so slope, they remind us here in the directions that slope is usually expressed with the variable m. And so we'll come back to that later, but another thing you might remember about slope is it's always, or it can be expressed as a fraction, typically is, and it's the change in y divided by the change in x. And sometimes we'll say it's the rise over the run. So what we want to do here is find what is the rise divided by the run here. So in order to do that, given a line like this, it's important to find 2 points on the line. And now I want to be careful, I want to be smart with the way I choose 2 points. For instance, this point might be hard to estimate what it actually is, because even though that is a point on the line, I can't tell if, like, it looks like this is negative 2 for the x-coordinate, but I can't tell if that's positive 2.5, positive 2 1/3 for the y one, for the y value, so I'm not going to use that point. I want to find a point where this line crosses at like the intersection, or really close to at least, the intersection of the x and the y coordinates. So here, this point right here, that looks pretty close. So I'm going to use that point. I'm just going to make a dot there. So I'm going to emphasize that I'm going to use that point for sure. And then find another one. So I might use like this one right here. That looks pretty close as well. So I'll use this point. And now I just want to find what's the rise over the run between these 2 points. So I like to always start at the leftmost point. So I'm going to start at this one. And then just count vertical distance up or down, which I'm going to go up in order to reach the same height as this point. And then the horizontal distance left or right, and in this case I need to go to the right. So I'm going to go up 1. So my vertical change, my change in y is up 1. So I'm going to put plus 1 there. That's my rise. And then my horizontal change, 1, 2, 3, is plus 3. The reason I know those are both plus, they're positive because I had to go up, that's the positive direction, and I had to go right in the positive direction. Now, if I would have gone to the left, in our typical understanding of a number line, the left, if I am moving from the right to the left, I am decreasing in value. And same thing for the vertical number line as well. As if I'm going up, I'm increasing. If I'm going down, I'm decreasing. So that's why those are both positive. So now I'm going to calculate this. So I need to express my slope. So I have m equals, well, it's my rise divided by my run. My rise was plus 1. My run was plus 3. And so I can't really do anything to simplify that fraction. So my slope is just 1/3 for this problem. So m is equal to 1/3. All right, and that's all. They just said find the slope. That's number 3. So then the next section is you're not given the line, you're actually given points. So if we wanted to, we could actually graph this. We could make an x and y axis and like plot the points 4, 5, and 6, 8, and then count what's the rise and run between those 2 points. Or we can use this formula they give us here. And maybe some of you remember this, and because we've used this in Algebra 1. You may have used it on occasion in geometry, but we've used it in Algebra 2 as well. So the change in y is customarily found by taking y2 minus y1, and the change in x is found x2 minus x1. And so I'm going to use that formula to calculate slope for these questions. So I'll just do number 5 and then a couple other special cases in this section, just to explain a few things. But number 5, I'm actually just going to copy down, I'm going to copy down the formula here. So I have m equals y2 minus y1 divided by x2 minus x1. So the reason these are named y2, y1, x2, x1 is we are given 4 different values. There's 4, 5, 6, and 8. And those are all going to go in a certain spot in this formula. So how this will work is each point is always, as we mentioned in the first problem we did today, was each point is an ordered pair, x comma y. So we're just going to say, well, 4, 5, that's the first point, so call those x1, y1, and 6, 8 is the second point, so call that x2, y2. So it doesn't mean, what the numbers don't mean is this means like there's 1x and here's 1y and here's 2x's and here's 2y's. No, this is just like another way of saying here's 1x and here's a different x. So it's like another way to name it. So x1 and x2 instead of assigning a value with that x. All right, so now what we're going to do is plug in these values into the respective locations and then do a little math. So we got y2, according to how we labeled it, would be an 8. I kind of covered it up with my markings here, but 8 minus 5 will go in the top, and then 6 minus 4 goes in the bottom. 8 minus 5 is 3, and 6 minus 4 is 2. So my slope, I cannot reduce that fraction at all. There's no number that would go in evenly to the 3 and the 2 at the same time. So I am, other than 1. So I'm done simplifying, and this is my slope, 3/2. Okay, now a couple special cases. I'll let you do most of these, but I do want to cover, looks like I want to do 7 and 9, and I'll show you why. So number 7. If I start to go through that same formula, something strange might happen. So I have y2 minus y1 divided by x2 minus x1, and I'm getting 2 minus 2 in the top and 3 minus a negative 1. So first, in the top, 2 minus 2 is 0. In the bottom, just remember if you have two negatives, 3 minus a negative 1, that's just like adding. So 3 plus 1 is 4. But 0 divided by anything is 0. So the slope is 0 for this problem. That's the answer. The slope between those 2 points is 0. And just a quick explanation on, well, what does that mean? What's the slope of 0? If this is my x-axis and this is my y-axis, I'll just kind of sketch where these points would be. Negative 1, comma 2 would be about here, and 3, comma 2, 1, 2, 3, comma 2 would be here. So the line through these 2 points would look like this. So this is a slope of 0 because it's like a flat line. Like if you were walking on a floor, a flat floor, you're not increasing in height or decreasing in height. You're staying at the same height. So the slope of this line is 0. And the height of this line on this xy coordinate plane is 2 always. It's always 2. If you look at this, the y value is 2 and 2. So the slope is not changing. It's always 0. The slope is always 0. And the height is always at 2. So kind of an interesting case there. And one more weird case would be number 9. So I want to talk about this one. So this one, when we start to go through the formula, m is equal to change in y, y2 minus y1, divided by change in x, x2 minus x1. And my y2 is 8, my y1 is 4, and my x2 is 0, and my x1 is also 0. So here we get 8 minus 4 is 4, and 0 minus 0 is 0. But here we have a problem. We cannot mathematically make sense of dividing something into 0 parts. It can't be done. And so our answer for this slope is undefined. This is an undefined slope. And just again, to kind of bring this back to what does this mean as a picture? Well, you have an x and a y-axis, and an undefined slope would look like this. If I graph these points, I've got 0, 4, so 1, 2, 3, 4, there's this point right here, and 0, 8, 5, 6, 7, 8, be somewhere here. So this line, let me use a different color, how about blue? This line would go through these 2 points, so it's actually the same as the y-axis. And this is an undefined slope, and if you think about my analogy earlier from like walking across a flat floor has a slope of 0, well, this would be like trying to walk up a wall, which you can't do unless you're Spider-Man. And so it's an undefined slope. So that is what that would look like as a picture. So that's this section when you're trying to find the slope between 2 points. Just a couple examples, and I'll let you finish the rest of those. And then you can always refer to the answer key we've included with the packet to check your work. But the next section is we're trying to graph lines now. So we have equations now expressed as several different forms. So some of these are in slope-intercept form, some of these are in standard form, and then a couple down at the bottom are maybe special cases of lines that I guess are technically standard form and slope-intercept form. But we've got these equations we want to sketch a graph of each line. So let's start with, I'll do number 11, number 13, and then probably both 15 and 16 at the bottom. All right, so number 11, this is in slope-intercept form, and just to remind you, how do I know that? How do I know it's in slope-intercept form? Well, let me write this. Slope-intercept form is y equals mx plus b. So essentially, whenever I see y, the variable y, isolated by itself, it's a pretty good indication that's in slope-intercept form. And typically, we write the the coefficient of x. Coefficient means the number in front. This is a number. X, we write that first, and then the constant term, the number by itself, last. So that coefficient of the x term, that number in front of x, is m, which is, if you remember from calculating slope, that's the number we use for slope. So that's why this is called slope-intercept form. This b value is actually the y-intercept. So if an equation like 11 and 12 is in slope-intercept form, the easiest way to do that is to use the slope and the intercept in order to graph it, because as soon as I get a point and the slope, I can graph a line pretty easy. So if you'll notice the answer key to this packet, it's labeled like this is the y-intercept and this is the slope. And so you'll want to start with the y-intercept, which is -5. So as a coordinate pair, that's 0, -5. And so we'll go on the y-axis and put a point at -5, 0, -5, that's that point. And then use this slope of 4 in order to find other points on the line. Because once I have 2 points, if you remember from geometry, you need at least 2 points to create a line. I only have 1 right now. So what we'll need is to make some more points, but our slope is 4, and in order to really get an understanding of where I should go, 4 can be expressed as a fraction as 4 over 1. If I divide 4 by 1, it's still 4. So I'm going to, from this point, the y-intercept, go up 4. So actually I'll use my laser pointer. Up 4, 1, 2, 3, 4, and then right 1. These are both positive numbers, so I go up 4, right 1, there's another point. And I always tell my students, do that as many times as you can to draw the most accurate line possible. So I'm going to go up 4, 1, until this coordinate grid runs out of room. Like that's as many points. I couldn't go down 4 over 1 because I'm off the grid, even though I could kind of guess it's about there. But right now I'm going to draw a line through all these points. And so there's my line. All right, so then that is my equation, or that is my line for y equals 4x minus 5. So that's it, I'm done. That's if it's in slope-intercept form. If it is not in slope-intercept form, for instance, number 13, you could change the form into slope-intercept form. And so I could do a little algebra and just move the x term over this side by subtracting x. Then I could divide by -3. I could divide everything in the equation by -3. And then it would be in slope-intercept form, and I could graph it just the same way that I did number 11. Or, if I didn't do it that way, I could choose to find x and y intercepts. And what an x and a y intercept is an x-intercept, for instance, is where this line will cross the x-axis. And the y-intercept is where this line will cross the y-axis. So to find those, thinking about a point on the x-axis, the y value, anywhere on this x-axis, the y value is going to be 0. So to find an x-intercept, in order to do that, I'm going to write this over here. To find an x-intercept, I'm going to plug in 0 for y and solve for x. So basically I'm saying, well, if y is 0, what is x? So if I take this equation and plug in 0 for y, I get the equation x minus 3 times 0 instead of y equals 6. And so by doing that, 3 times 0 is 0, so it's x minus 0 is 6, so basically x equals 6. So my x-intercept is at 6, 0. My x value is 6, my y value is 0. So that lets me draw this point on the graph. There's my x-intercept. And remember, I just need 2 points to graph a line. So when I do this for the y-intercept, I'm done. I can just draw a line between the x-intercept and the y-intercept, and I got the line. So I'm going to do that. I kind of am running out of room, so I'm going to maybe do this a little smaller. So if I plug in, I'm not going to write all those words I did for the x-intercept, but for the y-intercept, if I plug in 0 for the x value, I get this equation. I get 0 minus 3y equals 6. And so that's negative 3y equals 6. Divide by negative 3, and I get y equals negative 2. So that point would be 0, comma, negative 2. So I could put that point on the line. 0, negative 2 is this point. And then I can construct a line between these 2 points. I'm going to try my best to make this as close as I can. It's about that line. All right, so that's another method if it's in standard form, which 13 and 14 are both in standard form. You can choose to, if you want to, find intercepts instead of changing the form to look like number 11 and 12 and then graphing it that way. All right, then these last two, these are special cases for constructing lines. So this one case, 15, doesn't have an x in the equation at all, but it's still a line. And 16 doesn't have the variable y in the equation, but it's also still a line. Essentially what these are saying, number 15 for instance, is saying, I mean, this is, if you kind of think about it, this is y is equal to 5. Maybe to emphasize it, y is always equal to 5. And since we aren't given any information about x, x could literally be anything. And we say that x could be any number between negative infinity to positive infinity. So we want to draw a line that shows x could literally be anything, y can only be 5. So to do that, if you think about, well, where is y equal to 5? And remember, this is your y-axis, this is your x-axis. So y equals 5 would be here. But that's just one point where y is equal to 5. We want y could be 5 and x could be anything. Well, this is the point where y is equal to 5 and x is equal to 0. If I go to the right one spot, here's a spot where y is still equal to 5, but x isn't equal to 0 anymore. X is equal to 1. But remember, we want the line where y is equal to 5 and x could literally be anything. So I could continue drawing these dots in either direction, and you can start to see, oh wait, that's a line. That's a horizontal line. And so this is the line y equals 5. So kind of a special case when you are given an equation where x is not included, that is going to be a horizontal line. And so you just find where y equals 5 and draw a horizontal line through that point. And then similarly, the number 16, instead of y equals 5, this is x equals negative 2. So instead of a y equals line, this is an x equals line. So 16, I'll follow kind of the same reasoning. Well, I want a line where x is always equal to negative 2. But y could be anything. It could literally be anything from negative infinity, the most negative number you could ever think of, to positive infinity, the biggest number you could ever think of. So this, I want to find where is x equal to negative 2. And remember, this is my y-axis, this is my x-axis, so I want to pay attention to this horizontal line. X equals, here's 0, 0. There's 0, 0. So I want negative 1, negative 2. So right here, I'm going to draw a point there. And then negative 2, well, that's where x is equal to negative 2, y is equal to 0. If I go to the right one, x is not equal to negative 2 anymore. Now it's equal to negative 1. And that's not what I want. I want x to always be equal to negative 2. So I don't want to go to the right or to the left because that would be changing the value of x. We're told x is fixed. It can't be anything other than negative 2. So I want to change y instead, because y could be anything. So if I go up 1, then y is changed, but x remained the same. X is still negative 2. So I'd be getting all of these points. This point, this point, this point, down, 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 like all these points. So I'm getting a vertical line this time. So here's my equation for y equals negative 2. Okay. And just as a reminder, this has a slope of 0. And this slope is undefined. Just a quick refresh. Undefined. All right. All right, let's keep going. So now the rest of this packet is practicing writing equations. And so if you'll notice, questions 17 through 24 are practicing writing an equation in slope-intercept form. And we're reminded this is what slope-intercept form is. And then for questions 25 through 32, these we're told to write the equation in standard form, and we're reminded what standard form is. So let's go back and do a few of these for writing an equation in slope-intercept form. And here, I suppose I might go through how to do this perhaps a little differently than maybe if I'm not your teacher, if another teacher might explain this differently. There's the cool thing about mathematics is there are so many different ways to do something correctly. So to write an equation in slope-intercept form, I might teach it one way, another teacher would teach it a different way, but they're both correct. And the student, you have the opportunity to find out, explore different methods and decide which way is best for you. Is this way more efficient for you, or do you prefer doing it this way? And probably what it's good for you to see and be exposed to different methods. So I'll do a few different ways here, and so you can kind of decide. So I won't do all of these, but I'll start with the first one and go through these. So we are given a slope in the y-intercept. This one, I mean, I almost shouldn't do this one. It's so easy because if you notice, slope-intercept form, I need the slope, I need m, and I need b. That's my objective. As long as I get a value, a number or a fraction for m, and a value for b, which is the y-intercept, I'm done. I just got to write those two numbers in the right spot. So this one I'm actually already done because negative 2/3 is my m value. Positive 2 is my b value because it's my y-intercept. So when I start to piece together what is y equals mx plus b, I know it. I know this is negative 2/3 and this is positive 2. So I can write y equals negative 2/3 x plus 2. Done. And that's my slope-intercept form. It gets tricky when we're not given something super nice like that, where we're given, oh, the y-intercept is 2. It's so obvious. Instead, we're given just the slope, like for number 18, and a point on the line. And so I'm going to do this kind of the way that I typically do this in class, but then I'm going to do a different method on the next question to show just another way of doing it. So what I like to do, I like to think of this as somewhat of a puzzle. So I have an equation, y equals mx plus b. And to solve this puzzle, all I need is I need to find m and I need to find b. That's my objective. Good news, half the puzzle's done for me. Slope 4, I know what m is right at the beginning. So I'm even going to plug it in. Since I know what it is, I know I can rewrite this as y equals 4x plus b. And so now my only job for the rest of this problem is to figure out what is the b value, what is the y-intercept. And the only other piece of information I've been given is this. There's a point on the line located at 2, 1. So if you remember, We've talked about these ordered pairs quite a bit so far. Each ordered pair is an x value with a y value. And so I'm going to use that to my advantage because I know that when the x value is 2, the y value is 1. Or vice versa, when the y value is 1, the x value must be 2 for this line. So what I'm going to do is choose to plug in 2 for x and 1 for y into this equation. So this y value will become a 1, this x value will become a 2, but I'm going to rewrite it and not do it that way because that's kind of confusing. So y is 1, x is 2, and then solve this for b to find the missing piece of the puzzle, the last thing I needed to know to write this equation in slope-intercept form. So this would be 1 equals 8 plus b, subtract 8 from both sides, negative 7 equals b. I did it. I know what my missing piece is. I know my slope is 4, my y-intercept, my b value is negative 7, so I can write my final equation, y is equal to 4x minus 7. That's my equation in slope-intercept form. Then, so that's one way. I like to, I don't know, I feel like maybe that was just the way I learned it in high school, but a different way, which I know some teachers prefer to teach it this way, is using a form called point-slope form. And so that will look something like this. You may be familiar with this. Y minus y1 equals m times x minus x1. So before I continue, let me explain, if you're not familiar with this, what all of these are. So y is just the variable we'll use, just like we have been. So y and x without subscripts 1 and 2. Those are going to be like the x and y that go in our final equation in slope-intercept form. But when we put subscripts, that's like this number is, this 1 and this 1, that's a subscript. So y1 and x1, those come from a point. And we are given a point right here. Here's our point, negative 3, negative 4. So this gives me my x and y. We're going to use those numbers as x1 and y1. And then we've used slope quite a bit. This m value stands for the slope, and that's 3 over 2. So I'm going to plug in values for this y1, this m, and this x1. And then we'll see what happens from there. So I have y minus, well, y1 is negative 4, so I have technically two negatives, y minus a negative 4, equals 3 halves times x minus x1 minus a negative 3. All right, so here, I'm now going to start to simplify this. So I'm noticing that I have a minus a negative 4 here. I'm just going to clean that up to be y plus 4. Two negatives make a positive. And I'm going to distribute this. So 3 halves times x is 3 halves x. And then 3 halves times, careful here, this is minus a negative 3. So it's technically a positive 3. So I'm going to say plus, and I have to multiply 3 halves times 3. So just a quick refresh on how we do that. 3 halves times 3. 3 can be written as a fraction by writing it over 1. And for multiplying fractions, you're going to multiply across the top and across the bottom to get your fraction. So let me back up so there's not stuff going through those. But you're going to get 9 over 2. And so that's what I'm going to get here. So I have plus 9 halves. Now, keep in mind, our goal is to get this in slope-intercept form. So the only thing I just need to get y by itself. So I need to move this 4 to the other side of the equation, and then I've got it in slope-intercept form. So in order to move that 4, I'm going to subtract it. I do the inverse operation of addition. So I'm going to subtract 4 from that side and just get y. But remember, whatever you do to one side, you have to do to the other. But I'm going to be strategic with where I write this, because I don't want to write the negative 4 here, because that would be subtracting 4 from a linear term and not a constant term. A linear term is a term with an x, or just a one variable on it, an x. And here, this is the constant term. Well, I'm subtracting a constant. I want to subtract from the other constant. So instead of minus 4 there, I'm going to write minus 4 here. And if I'm subtracting 4 from a fraction with a 2 in the denominator, I like to just say, well, if I'm subtracting 4, that's the same thing as subtracting what number over 2? Because I'd like, if I'm subtracting fractions, to have the same denominator. So if I'm subtracting 4, that'd be the same thing as, well, this is technically like a 4 over 1. So if I multiply the denominator by 2 to get it to be a 2, I got to multiply the numerator by 2. So that's like subtracting 8 over 2. And so if I have positive 9 over 2 minus 8 over 2, I'm getting positive 1 over 2. So this would be plus 1/2. And so bring down the 3/2 x. And there is my slope-intercept form. Y equals 3/2 x plus 1/2. Okay. Sweet. So that is point slope form, if you are familiar with using that, or if that's the first time you saw it and you're like, wow, that's awesome, I want to do that, I like that a lot better, you can do that. Like I said, there are several different ways to do the same thing. Oh, that's really a bummer that all of this is now frozen. I'm going to delete that, so you can always back up this video if you need to, but right now it's doing something I don't want it to do, so I'm just going to delete it. Okay. 2 points on the line. So if you are given 2 points, you need to find the slope first. So you need to find, I'm going to say need slope. So that means we need to use that y2 minus y1 over x2 minus x1 formula to find what is our slope. That's our m value. But then once we have that, we can use one of these points and the slope to treat this problem just like number 18 or number 19. So I'm not going to go through this whole problem just to save time for this video, but you can always use the answer key to check your work. But find the slope, then use one of those points. Actually, doesn't matter. You could use 1, 0 or negative 3, 8, and it will get you to the same spot eventually. I always tell my students, use the easier numbers. 1 and 0 look a lot easier to use than negative 3 and 8. So use those 2 pieces of information to find your equation. So what I definitely want to talk about here is some of these questions like 22, 23, and 24 talk about parallel and perpendicular lines. So just a quick refresher. This piece of information, when it says parallel or when it says perpendicular, it's basically telling you what the slope of your line is. That's the purpose of that clue. So as a refresher, if you remember from geometry, let's think about the coordinate plane, and I'm just going to draw an arbitrary line here. So let's say this is the line, well, let me make it a little more realistic. Let's draw the line y equals x plus 1, so something like this. Well, you get the idea. Make that big. So let's say that's the line y equals x plus 1. This line that I'm trying to write an equation for will be parallel to that black line. So parallel means that these 2 lines will never intersect. So as a visual, the visual representation might look something like this. Maybe it looks something like this. So in geometry, you probably expressed it on a picture by drawing little triangles or like something like this to show these 2 lines are parallel. And so these lines will never intersect, will never cross. So if you look at those 2 lines and maybe guess what would the slope, or how would the slopes of these 2 lines be related? How would they be related to one another? So if you think about it, this even looks like, man, these slopes look like they're pretty close to the same, because if I go up, you know, I don't have the whole grid here, but if I go up 1 over 1, that's the slope of this line because it's 1 in front of that x. this is also the same. And as a graph, parallel lines have equal slopes. So you just need to remember that. If it's a parallel line, it's going to be equal slopes. So that means the slope that I want to use for number 22 is my slope is 1, because that's the number in front of that x. That's the slope, 1. So now I have slope and I have a point. I can treat this just like the problems before to find this equation. So I'm not going to go through all the steps. You can check the answer key for sure to check your work. But that's how you would get past this first clue of how do I find the slope if all I know is parallel to this line. Then, what if it's perpendicular? So going back to geometry again, I'm actually going to use this same graph. Let's use a different color though. Let's use yellow. So a perpendicular line means that it's going to be, it's going to meet this black line at a right angle. So I'm going to just draw close and just guessing. So a right angle means 90 degrees. In geometry, we express that as like a little box right there. So these slopes end up being what we call, sometimes teachers will say negative reciprocals, or I prefer to use a different word than negative just to make it more obvious, but they are opposite reciprocals. And what that means is if the slope of this black line is m equals 1, or as a fraction, that's 1 over 1, the opposite reciprocal means whatever the sign is, this is a positive 1 over 1, then the slope of this yellow line is going to be negative. Positive, the yellow line's negative. So I know slope of the yellow line is going to be negative. Reciprocal is like saying the flipped version of this fraction. Now this is kind of a bad example because it's 1 over 1. So the flipped version of 1 over 1 is still 1 over 1. But that's what it would be for this one. But if you look at 24, question 24 says it's perpendicular to the line y equals 2/3 x plus 1. So here's the slope, 2/3 of this line. But the line that we want to draw is perpendicular to this line. So I want the slope perpendicular to 2/3. Therefore, I want the slope that's the opposite reciprocal of 2/3. So opposite of positive, since this is positive 2/3, is negative. So m is definitely a negative slope. And flip this fraction. So 3 is now on the top, 2 is now on the bottom. So negative 3/2. This is the slope, and here's a point. Use these two pieces of information for 24 to find your answer. Okay, so this video is getting kind of long, but the last section here just talks about standard form. So the steps for or how you will complete questions 25 through 32 are pretty similar to, you could always write it in slope-intercept form. So do exactly what you did for the last 6 questions, but then change it into standard form. But I just want to remind you some things about standard form. And so I'll remind you about some things, and then I'll do number 25 and maybe like 27 or something like that. Maybe I'll just do the first two, 25 and 26. And that will tell you just some things about standard form that will be important to remember. So standard form, let's talk about this form here. It's ax plus by equals c. So we know what x and y are. We've used those a lot. But what are these? They're introducing new letters here, a, b, and c. A, b, and c, I'm going to write this down. A, B, and C are all whole numbers, and actually integers, because B and C can be negative. So I'm going to say are all integers. Essentially, they can't be fractions. And we'll talk about how do you make them not fractions later. But a, b, and c are all integers. And then even further, customarily, a is always positive. So a is always a positive number. So if it's negative, we'll multiply or divide by -1 and make it a positive number. So a, b, and c are all integers, and a is positive. That's standard form. So let's see what this looks like. So you remember 25 in the previous section, this first question in the previous section was super easy because we were given a slope and we were given the y-intercept to write it in slope-intercept form. So in slope-intercept form, this would be 2/3 x minus 1. That's slope-intercept form. But standard form has x and y on the same side of the equation. Well, I already have y on the left side, so all I would really need to do is move this x term over, and now they're on the same side, and there's a constant -1 on the other side. So that's what I'm going to do. I'm going to subtract in order to move that positive 2/3. Subtract 2/3 x from both sides. And that's going to give me -2/3 x plus y equals -1. So then all I need to do to get this in standard form is I need to get rid of all the fractions. I only have one fraction, but I can't have any fractions. I need them, all these numbers in front, the coefficients of the x term, the y term, and this constant. I need those all to be integers. Well, -1's an integer, +1's an integer, but -2/3 is a rational number. It's not an integer. So in order to do that, you want to multiply the entire equation by 3. I'm choosing 3 because 3 is in the denominator, and if I choose to multiply -2/3 by 3, these 3's divide out or cancel out, and I'm left with -2x. And then the 3 will then be applied to positive y, and the 3 will be applied to -1. Even further, though, I want to be smart before I do that, because if I multiply by 3, I'm going to get -2x here. But remember, a is supposed to be positive, so I don't really want to do 3. I would rather do, to save myself the time, a -3 in the beginning, because that would make this, when I distribute, that would make this a positive 2x, and that saves me a step. Then -3 times y is -3y, and -3 times -1 is positive 3. All right, so that is standard form for that first equation. All right, so that's one method. You could write it in slope-intercept form first and then change it into standard form like I've done. So let's go down. I'll actually, maybe rather than doing 26, I'll jump down and do one of these perpendicular or parallel ones. And I'm going to have to delete this just so it doesn't follow us. Okay. So let's just do the last one, or one of these. I don't remember. Let's just do 31. So 31, I want a line perpendicular to this line. So if my slope of a line is 4/3, the perpendicular slope is the opposite reciprocal. So it's going to be -3/4. That's the slope I'll use. And then I'm going to use this point. So for this problem, I'll use point slope form, just in case some of you are more familiar with that. So I'm going to write point slope, y minus y1 equals m times x minus x1. And so I've got my m, that's right here, and here's my x1, y1. x1 is -4, y1 is 3. So I'm going to plug those in. Y minus y1, y1 is 3. M is -3/4. X is just x, but x1 is -4. Notice, don't forget about this double negative. That's a common mistake. After a few years of teaching, I noticed that that's a pretty common mistake that people will make. The formula here is minus and the next one is negative. So you have to have a minus, then the negative 4, which is eventually going to make that a plus. So I'm going to distribute, and I'm going to get y minus 3 equals negative 3/4 x, and then negative 3/4 times, this is really a plus 4. I'm going to go over to the side and just talk about that. Negative 3/4 times 4, that's like 4 over 1. So when I look at these two things, I'm noticing there's a 4 in the top and a 4 in the bottom. They actually will cancel out, and so, or divide out. And that's going to give me negative 3. All right, so minus 3 goes there. Okay, now to get this in standard form, I need to move the x term to the left side and move this other term to the other side. So I need to add 3/4 x and add 3/4 x, and that's going to give me 3/4 x plus y minus 3 equals negative 3. And then I need to move the minus 3, so I'm going to add 3. You could have done those at the same time. I'm just going one step at a time. So that gives me 3/4 x plus y equals negative 3 plus 3 is 0. But then remember, I can't have any fractions. I can't have rationals. I need to have integers only. So I'm going to multiply this entire equation by 4 to each of those parts. And so the 4's divide out, I get 3x, 4 times y is 4y, 0 times anything is still 0. So there is standard form for question 31. All right, sorry this video is so long. Hopefully you can just fast forward to different parts you needed if you didn't need the entire video. But hope it was useful. But feel free to shoot myself an email or your teacher an email if you have further questions.